morning, friends. I am Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. I am starting the course which is Aircraft Stability and Control. This course is essential to understand how the aircraft will be stable, unstable, and how this control of the aircraft can be achieved. Today, I am starting with lecture number 1, that is Introduction of Aircraft Stability and Control. In this class, I am going to take these topics: Introduction to Stability and Control, Access System, Control Surfaces, definitions like equilibrium, static stability, controllability, and maneuverability. These topics I am going to cover in today's class. As far introduction is concerned, I have to go with some historical perspective because we have to understand how these things have evolved. So, aircraft stability and control. In this, if you see, first term is aircraft. So, first we should know about the 3 words in this course, that is aircraft, stability, and control. So, first word is aircraft. So, what is the aircraft? An aircraft is a vehicle that is able to fly by gaining support from the air. It counters the force of gravity by using either static lift or by using the dynamic lift of an airfoil, or in a few cases the downward thrust from jet engine. Here I have shown the 3 aircrafts. One is the fixed wing aircraft, which is shown here. Another is rotary wing, it is also called the helicopter. And third one is a flapping wing or ornithopter. These all 3 are man-made aircrafts. Now, I will go with the historical perspective, how this aircraft has come up, who all are the responsible people who have their contribution towards development of aircrafts. So, control and stability of aircraft. The first person who have taken consideration of these terms, control and stability, are the Wright brothers. These Wright brothers we have achieved was to find the masterly of the 3 main areas which required by functional airplane. These areas are lift, propulsion, and the control. So, first 2, that is the lift and the propulsion, have been studied very rigorously by many researchers like Sir George Cayley, Otto Lilienthal, Octave Chanute, and Samuel Langley. The bigger innovation of Wright brothers flyer was control system. In this, if you see, this is the biggest contribution, the control from these 2 brothers, and that is why this is the Wilbur brothers and this is the Wright brothers. Okay, so these are the 2 brothers. They have contributed towards the control of the aircraft. Next, few important personalities who have worked in the domain of aeronautics. Their contribution is enormous towards funding the aircraft stability and to develop the aircraft. The first credit goes to the George Cayley. the George Kelly, the first true scientific aerial investigator and the first person to understand the underlying principle of the force of flight. Another very important researcher is Otto Lilienthal, known as the flying man. You can see here, this is the Otto Lilienthal. He is flying in a glider and lot of credit goes to him for Wright brothers. Wright brothers have tried to copy his technology and they were also guided by Otto Lilienthal, and this both George Kelly and the Otto Lilienthal, they were giving the guidance to the Wright brothers. So this Wright brother, known as this Otto Lilienthal, is known as the flying man, first person to make well documented repeated successful flight with glider. He has made a very successful flight. He has landed safely, and the credit goes that he is the first man who has flown the glider in this earth. Some more important people, you can see Octave Chanute. He was hailed as the father of the aviation and the heavier than air flying machine. He is the person who has well documented his research, and he has the person who has started that heavier than air aircraft can fly. He provided advice to Wright brothers. He was the mentor of these two Wright brothers. These pictures are here for these two Wright brothers in this, and Octave Chanute, he was the mentor and he was giving guidance to these two brothers. Samuel Langley is also a very renowned scientist and engineer of aeronautics, and in NASA his contribution was tremendous and a full lab is given on his name. Langley was the founder of the Smithsonian Astrophysical Observatory and one of the great person in NASA who has worked towards the development of the aeronautical of the earth. Next, I will start with the very basics of aircraft stability and control. You will see here that before this thing, I would like to say that this is the aircraft. In this aircraft, this is a forward. If it is the pilot is sitting at the center of gravity, towards the nose is positive X. Towards the right wing, there is the right wing. So this is the right wing is a positive Y, and towards this is yaw axis. So this is the pitch axis. This is the roll axis. So the roll axis, this is the pitch axis, and this is the yaw axis. So we have the body axis system, we have the three axis system, that is the pitch axis, roll axis and yaw axis system as shown in the diagram. You can see here that this pitch axis, the arrow, if it is positive, nose up. So this is the positive pitch and this is the negative pitch. If nose is going towards the right, this is the positive yaw, and if this is moving towards this left, it is a negative yaw. Same way, if this rolling, if the wing is going, right wing is going down, right wing is down, it is a positive, and left wing is going down, it is negative. So like this, we have to emphasize which is positive and which is negative. Now, another is axis representation, how we can represent the axis system. These are the two diagram here. First I will go with this. Here you can see this is the Earth axis system. Earth axis system. In this, towards the north, it is a X. Towards the wing, it is a east, and towards the down, it is a towards the center of the earth. So this is the platform aligned to north, east, and down. So this is the Earth axis system. Here in this, you can see that this is the x-axis or longitudinal axis. This is the your arbitrary platform orientation, and this is the transverse axis or lateral axis. So different types of axes are there, and different names are suggested for different types of axes. These are useful for determining the equations of motion that we'll be studying in our module 3 module, where you can understand how the transformation of one axis system to another is required, and what is the necessity of transferring from one axis system to another axis system. Here just I am going to talk about the control surfaces, and these control surfaces, if you see here, I have shown here the primary control surfaces. You can see here that these are the ailerons, this aileron, right and left. Here is the flaps. These are the elevators in the horizontal tail, black color. These are the elevator, and this is the rudder. It is mentioned here, rudder. Okay, so these are the three primary control surfaces. These control surfaces are aileron for the roll. If you tilt or deflect this aileron downwards, the lift of this wing will be up, and this will go opposite direction. If this is down, this will go up. So lift of this thing will be down. Aircraft will roll towards the left. So if you want to roll the aircraft towards the left, then right side aileron should go down, and left side aileron should go up. So aircraft will turn towards the roll towards the left. If you want to make aircraft to turn roll towards the right, then left aileron should go down and right aileron should go up. So the lift in this side will be high and lift inside will be low. So aircraft will try to roll right wing down. Same way, if you want to make nose up, nose down, this is called the pitching motion, and this pitching motion is achieved by the help of elevator. In this, elevators are fixed at the horizontal tail behind the aircraft so that it can get leverage of the aircraft from the center of gravity. We are putting a very much behind so that a small size of horizontal stabilizer can be utilized for doing this work. When elevators are put down, the lift of the tail will be high and aircraft nose will go down. If you put this elevator up, then the lift of the horizontal tail will be reduced and this will go up. So if you want to make nose down, elevator should go down. If you want to make nose up, elevator should go up. Third primary control surface is rudder. These rudders are used to make yawing motion. Yawing means nose left, nose right. So how this nose will go left? To make the nose left, we should have more force here. It means your rudder should go left. So if this rudder goes towards like this, the aerodynamic forces will be in this direction and it will turn like this. So aircraft will be moving towards the left. If you want to turn your aircraft towards the right, means we should generate a force in the left direction. So your rudder should move in this direction like this. So the aerodynamic forces will be in this direction, and there will be a moment from this. It will try to make the aircraft in this direction. So in this way, the yawing moment is achieved. I have explained all the three primary control surfaces, and in this way, aircraft is taking different moments, different directions. So next I will go with some definitions. So first is equilibrium. So what is the equilibrium? If a system is an equilibrium state, return to equilibrium following a small disturbance, the state is said to be stable equilibrium, as shown in the next diagram. I will show you. On the other hand, if the system diverges from equilibrium, it means it goes beyond the equilibrium condition. When slightly disturbed, the state is said to be unstable equilibrium. Strictly speaking, figure 1D is also a case of stable, because a very small disturbances from equilibrium would result in a force and moment imbalance that would return the balls to its original equilibrium state. But a little extra disturbance towards right could cause the ball to move past the apex, which would produce a force and moment, which imbalances would cause the ball to move away from its original equilibrium state. You can see here, I have shown the three diagrams here, and here states of the equilibrium. Figure 1A shows the stable equilibrium. As disturbed force removed, the balls will restore its original position. You can see here that when this ball is here and you have disturbed from here to here, it will try to come again here, like this, and after some time it will come again. So the tendency of this ball is to return to its equilibrium position. If like this, then we can say that aircraft is statically stable, or any object is statically stable. The second case, if you revert this and you put a ball on upper side of this, and if you give a small disturbance, it will shift to new position, but it will not come back. It will try to go away. It is called the diverging. So this ball will never come back to its original, but it will go away from its equilibrium. Then we can say that this is the unstable equilibrium. Okay, and this is the case if a ball is on the table and you have put a ball here and you have disturbed from one place, it will go to the new place, this, and it will remain in this new position. This is called the neutral equilibrium condition. Here another case is there. This ball is here. If you give a little force, it will go up to here and it will again come down. It will go here, again it will come down. But if you increase little more force, it will go here and it will never come down. So it is case for certain condition, up to certain disturbing force, it is stable, and when you increase the force more than that critical force, it will become unstable. So like this, we can describe different types of equilibrium, states of the equilibrium, and in this, stable, unstable, neutral is stable, but also stable and unstable depend upon the application of the force. Okay, so now I will go for the stability. What is the stability? So there are two types of stability as mentioned below. Stability has got the static stability and the dynamic stability. So static stability, if an aircraft disturbed from equilibrium state and has the initial tendency to return to its equilibrium state, then the aircraft is assumed to have static stability. It means what? This is the aircraft. aircraft is flying like this, some disturbing force such as gust, it has hit here and it has gone up. Whenever this force is removed, whether this tendency of this aircraft is towards the equilibrium position or not. If the tendency is towards that, we can say that aircraft is statically stable. In the second case, we have the dynamic stability. In the dynamic stability, aircraft is flying, some disturbing force like a gust has come, aircraft has gone up. The tendency of this thing is there to come, but it depends upon how much time it is taking. It is taking like this, and after some time it is coming to its equilibrium position. So whenever a finite time is involved and the amplitude of these motions are decaying or reducing, then we can say that aircraft is dynamically stable. So this is the two types of stability, and this we can say that it is dynamically stable. Next is controllability. So controllability, the response of an aircraft in steady flight on pilot control input. For instance, deflecting the aileron, a high resulting roll rate means a fast response. The relationship between stability and controllability has been that greater stability means less controllability and vice versa. An aircraft becomes less controllable, especially at slow flight speed, as the CG is moved further aft. So if the center of gravity of the aircraft is moved aft, the aircraft will become less stable. Next is the maneuverability. This maneuverability is also opposite to the stability. It is the ability to change the direction of motion of a body, normally a vehicle or aircraft, without any loss in speed with which the body moving. Maneuver is nothing but when a body moving at a certain speed which changes its direction and attains the same initial speed at which the body was moving before changing the direction. So we can consider an aircraft traveling at 500 kilometers per hour towards the north, which changes its direction towards the south and again reaches 500 kilometers per hour within 10 seconds, have high maneuverability than an aircraft traveling at 5 kilometers per hour towards the north, which changes its direction towards the south and reaches again in 500 kilometers within 30 seconds. So just I will explain the meaning of the maneuverability. If one aircraft is flying and it is flying towards the north, due to some control deflection, you want to move this towards the east. During the moving the east, the velocity of this thing, initially it was 500, but now it has become 450. But after turning, it takes 10 seconds to reach again 500 kilometers per hour. So another aircraft which is also going in the same speed 500, a turning is given towards the east. It has turned towards the east. The velocity of the aircraft has now 450. From 450 to 500, it is taking 30 seconds. So the first aircraft who has taken only 10 seconds to recover its speed, that is much maneuverable than another aircraft which is taking 30 seconds to reach its original position or original speed or intended speed. So we can say that the aircraft A, which is taking less time to reach to its equilibrium position, is much maneuverable than another aircraft which is taking more time to reach its intended flight conditions. So this is the explanation. These are the references: Yachout TR, Introduction to Aircraft Flight Mechanics, AIAA Education Series 2003, ISBN, Nelson RC, Flight Stability and Automatic Control, and then Dynamics of the Flight by Itkin. These are my references. Thank you very much for joining the class. Please continue with watching my next class, and please like it and put the bell icon and subscribe it if you feel it is good for your career, for your knowledge. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.